What's up, math scholars? Mrs. Harp coming at you with a study guide video, 4.3 to 4.5. I'm recording this early just in case I'm sick tomorrow because you just never know. All right, feel free to click pause, rewind, take your time if I end up going too fast to do these problems. For the first three, we're going to kind of use that left, right, center technique to solve for the missing variables. Just keep in mind, with logarithms, the base is located right here as a subscript on the right. The exponent is over here on the, on the left. The base is on the left. The exponent's on the right, and then the solution's in the center. And that's why you hear me say left, right, center a lot. Okay. So number one, 3 ends up being our base. 4 ends up being our exponent. And then x ends up being our solution. So just calculate out 3 to the 4th, and you'll have your answer. X is 81. All right, number 2. Let's also write this in exponential form. The 2 is your base. The y is your exponent. And then the solution is 32. So you're just figuring out what exponent you could use to turn the 2 into the 32. If you can figure it out in your head, awesome. It's 5. If you can't figure it out in your head, what I'm putting in the blue box, you actually could type in the calculator. You can use that special log button. The best way to get to the log button is hit math, and then alpha, and then math. So thanks to Livy Ash for coming up with that method to getting that log button. That'll give you the answer of 5. All right, and finally, number 3. 2 to what power will be 1/16? So first of all, I think 2 to what power will be 16? 2 to the 4th power will be 16. So it'll be 2 to the negative 4th power. It'll be 1/16 because of that whole flip and make it positive rule. Again, if you can't figure that answer out of -4 in your head, you can definitely just use that log button. Math, alpha, math, you put a 2 in the little box and the 1/16 in the big box. But it will yield the solution of -4. Moving right along, looks like more of the same. 27 to what power would give me 3? I do know that the cube root of 27 is 3, and if I want to do cube root, I would do the 1/3 power. So it looks like that exponent would be 1/3. You can definitely type it in the calculator, math, alpha, math, put 27 in the small box and 3 in the bigger box. Give you that 1/3. Number 5. We're going to do 32 as our base, 3/5 as our exponent, and see what answer we get. So in the calculator, just do 32, caret key, 3/5. Ends up being 8. And the last one, this is the one that people have been struggling with this week, just remembering the technique to solving. So our base is unknown, that's our C. 1/6 is the exponent, and then 2 is the solution. So we kind of talked about how we can make that 1/6 disappear. The only way to do so is to raise both sides to the reciprocal power, and the reciprocal power would be the 6th power. The reciprocal power would cause the 1/6 to disappear, so the answer is 2 to the 6th, or 64. All right, number 6, we did this stuff on Monday, our first day back from break, just kind of using the exponent rules to simplify down. We don't need a decimal answer. In fact, we don't want a decimal answer. We just want these things simplified down as best we can. The 12 and the 3 are just normal numbers, so you're going to do 12 times 3 to get 36. And then the e's, you're going to want to use your rule of the exponents to combine the 5 and the 6, and you would end up adding. So 5 plus 6 is 11. There's that one. Number 7, the 12 and the 4 are normal, everyday numbers. So you're just going to want to divide them. 12 divided by 4 equals 3. Now I do have a song for how we're going to deal with those exponents. Here's how it goes. Bigger minus smaller. Put the answer where the bigger lived. 13 minus 5. 13 minus 5 is 8, and we'll put that answer down below in the denominator. So that's where the biggest exponent had originally lived. And then number 8. That 2 on the outside has to distribute to everybody. So we have to do 4 squared, and we have to do e squared squared. Now that 2 and that 2 will multiply, so it'll be e to the 4th. But the final answer will be 16 e to the 4th. Alright, looks like we're trying to simplify this. I was just kind of thinking about the strategy one we want to use for number 9. It does have a base of e. ln always has an invisible base e, and then to me, that kind of pops out as the cancellation rule. So all of this stuff here will have the value of 1/3. We'll still have the 6 hanging out, but we'll just get our answer by typing 6 times 1/3. So it's 2. Now we definitely could check our work. If you're unsure if you did that right, let's go back to the beginning, head to our calculator. In fact, I'll even grab my calculator so you can see how I'm going to check this. We're going to do 6 times ln e, the e button is second division key, to the 1/3. So everybody cross your fingers, we get 2. Uh-oh. Let's think about how we made a mistake here. Oh, I know what I did. I think that, hope I don't have to redo my video. I hate making mistakes in my video. I'm so sorry, guys. So 6 times ln e to the 1/3. I think I should have had it in the parentheses like this. There we go. There we go. So it was me typing it wrong. That 1/3 needs to go in the parentheses because it is attached to the e. Sorry about that. Number 10, log 5, 125 to the 2x. It's popping out this might be a cancel property problem. So what I'm going to do is take that 125 and rewrite it. 125 does equal 5 to the 3rd. And then I'll still have the 2x out front. Now that it's rewritten, I can just cancel this out, leaving me with nothing except the 3 and the 2x. Multiplied together gives me the answer of 6x. So you take that 125 and you rewrite it to make it cancelable. We were talking about that in 4th period, whether cancelable is a word, and they said anything you say as a word is a word. I will go with that. All right, looks like we're heading on to graphing, so I'll pull my calculator back up. So we want our special log button. Alpha math is your best bet to get that. Put a 4 as the base and an x as in the parentheses. There's no shift on this, so our asymptote will be just right there at 0. Once we click graph, unfortunately, it does look like the graph is stopping right there around -2. You just have to be smart enough to realize it continues. It's just that the numbers get so small. The calculator doesn't actually physically graph them. But you have this asymptote running vertically at the equation x equals 0. That's the equation of that asymptote. So your graph kind of just comes in, looks like it crosses at 1, and just kind of hugs along that asymptote the whole way down to -infinity. It's going to make your domain 0 through infinity, not including 0, in your range -infinity to infinity. Table of values. Do a second table. And you're going to see a whole bunch of errors. That's because we can't take the log of a negative button. So it's error for the first 4 entries down through 0. Then it's 0, 0.5, and 0.79. Okay. Number 12, we're graphing with e this time. This is going to be either exponential growth or decay. make a guess on what you think it is before we graph it. So e to the x minus 4 power minus 5. So if you guessed exponential growth, you're right. That minus 5 did cause a vertical shift, and that's what's going to move your asymptote. So your asymptote is actually down there at -5 right now. Y equals -5 is the equation of that. That's your equation of your asymptote. Y equals -5. This graph has been translated 5 units down, as we just talked about. Now this number, that number is going to be your horizontal shift, and it's opposite from what you would guess, because that's how horizontal shift works. So it's 4 units to the right. 4 units right, 5 down. Look at it one last time to get my sketch. Looks like it's crossing at about 1, 2, 3, 4, 5, 6, 5.5 maybe. Kind of coming down and then just hugging along the asymptote all the way to -infinity. It's going to make your domain -infinity to infinity, and your range -5 through infinity, asymptote to infinity. All right, time to look at our table. So hit second graph to pull up that table. I'm just going to go ahead and run down and write my value starting at -3. That's -4.99. You can see it's really close to -5, but never quite touching. -4.99 again. -4.98. Now our values start growing. -4.95, -4.87, and -4.63. Okay. Oops, I skipped one. Number 13, solve for the unknown variable. On these, you're going to want to use those properties. We had 3 properties we learned: product property, quotient property, and leapfrog property. You're going to want to use the properties to make the left-hand side look like the right-hand side, and that allows you to draw conclusions. So first things first, to make my left look like my right, I'm going to have to condense that left-hand side. We're going to use the product property, and the product property just states if you have a plus sign there, you can condense by using multiplication. So multiplication and addition are friends. 6 times 10 will give me 60. So I've got log 60 on my left side and log 5a on my right side. Now at this point, you got to use your thinking brain to just kind of draw a logical conclusion. If you have that log 60 equals log 5a, you can conclude that 60 has to equal 5a. And you can just divide both sides by 5. 12. You can definitely check your work. Go back to the top, type in log 6, close the parentheses, plus log 10, close the parentheses. That's 1.778. And then take log 60 and just make sure it's 1.778. And it is, so check. Right, same deal. We're going to make that left-hand side look like the right-hand side to draw a conclusion about k. Just a real quick reminder, this is a 1/2. I don't know why I didn't print out that good. I'm bored. But you want to do any leapfrogging first and then just work left to right. So we're going to leapfrog this 1/2 up. 25 to the 1/2 power is the same thing as the square root of 25. So it's just going to be a 5. At this point, I can work left to right. Subtraction is friends with division. That's the quotient rule. So you're going to do 85 divided by 17. 85 divided by 17, and that's 5. Now, all of these have bases of 10. So we can't really do any canceling or anything, but we can do further condensing. Adding is friends with multiplying. That's the quotient rule. So we're going to do 5 times 5 and get 25. And then your left-hand side looks like your right. And you can draw that logical conclusion. If log 25 equals log k, 25 equals k. All right, we got Henry here depositing money. The key is looking for keywords to figure out what formula we're using. This money is compounding continuously, and that's the brand new formula that we just learned about this week. It's on the board. Where P is your principal, the original amount of money he puts in. E is that E button on the calculator. Your rate is the 6.5%, but as a decimal, so 0.065. And then it looks like the money's gonna be there for 15 years. So let's grab my big calculator and show you guys how to type that in. Let's move it out of the way. So 245, the E button is second division key. Practice typing this in before the quiz day, please. 0.065 times 15. $649.54. And now my favorite, finding the inverse. Looks like our last two. I have a song for this. Switch the x and y, then re-solve it. So you do want to keep in mind if you start with something in exponential form, you're going to end with something in logarithmic form. It's just because exponentials and logarithmics are inverses. So we are starting in number 16 in exponential form. 12 is the base, x plus 3 is the exponent, and y is the answer. So let's do our switch. 12 to the y plus 3 equals x. That's switching x and y. Now to resolve it, we're simply going to put it in logarithmic form, and the solving almost takes care of itself. 12 is the base, so it gets placed right here. Y plus 3 is the exponent. It gets placed over here. And then x is the solution. It gets placed right here. We are trying to solve for y, so we do have one last step of moving the 3 over, but then you'll be done. So here is the inverse, log base 12 of x minus 3. So hopefully that went well. Over here, we're currently in logarithmic form, so our final answer will be in exponential form, but let's do our steps to finding inverse. Switch the x and y, then resolve it. So here's me switching my x with my y. And now to resolve it, we're going to turn it into exponential form. 12 is my base, x is my exponent, and y plus 5 is my answer. Since I'm solving for y, I only have one more step to perform, and that's subtracting x on both sides. 12 to the x minus 5 equals y. All right, well, thanks for joining me. 18 minutes, that was not bad. We'll be doing further practice on Monday and get ready for the quiz on Tuesday. Have a great weekend.